what we're seeing, especially in these use cases, is how they apply Domo. When you plug it in, what it does, it turns the machine into hyperdrive, right? And the amount of not only improvement you can do, but the output of the value exponentially increases from the shop floor out. And we're starting to see this shift. I mean, the way that we used to do reporting looks kind of like this funnel on the left, where we've got all of this data and all of this time that we're doing, I should put this down, all of this time to produce an output that is okay, but could be better. And what I think is funny as we're looking at this, the one on the left, it actually looks like a bottleneck that we're creating by the process of the manual reporting and the manual output. But what we're seeing with Domo is it's almost in reverse, where by going through the activity and figuring out what it is that we want to measure, the data, where is it, and funneling it in, but in a concentrated focus, right? It could be big, it could be small, but by using Domo, the output is exponentially bigger. And that's what I think you're going to see here today, and the transformation that's happening with these guys, and I'm really excited for them to share their stories. So, we're going to start with Joe Newman from Aisin. Joe's been a customer of mine for, what, Joe? 10 months? Yeah. For his implementation, but they've been a customer going on almost 2 years, and they're doing some really exciting things, starting at the plant floor, right? Joe?
Awesome.
Joe?
Okay, thanks. Just a little bit about Aisin, the company, the group. Aisin is a $35 billion company, global company. We are the world's 6th largest tier 1 supplier. We are a Toyota company, affiliated with Toyota. We have about 100,000 or more employees across the globe. In North America, we have about 27 plants. I'm at Aisin Drivetrain, which is a facility that produces transmissions, electronic steering columns, industrial forklift transmissions. Background on me, just a quick background. I was a former college basketball coach, high school basketball coach, and a behavioral consultant in special education. And so I've only been in automotive manufacturing less than 3 years. So you're probably wondering, why is this guy speaking? However, using things, the philosophy and the methodologies in the educational background, I have actually applied into the quality sector at our manufacturing plant. And as I've been going through this process, and I'll tell you this use case and sort of how I brought Domo into it, it was all about data and how we were using it. So for Aisin, our mantra is quality first. Quality is cost, right? Quality is efficiency. Quality is scrap. Defect rates. Quality is customer relationships. If your customer's happy because of great quality, they're going to continue to keep buying your product, right? We also are trying to be an irreplaceable supplier, an actual supplier that works cooperatively with our OEMs. And our OEMs are Chrysler, Toyota, Nissan, Hino, Subaru, Suzuki, you name it. But not just a supplier that's just given product, but someone that you're working hand in hand with, okay? And in some of our use cases we have here, we're getting to that point. This is prototypical of a manufacturing plant. Those of you who've been in it. Aisin is a pretty heavy manual company, manual processes. We do machining and assembly, but it's very man-dependent, right? And so there's risk in the man processes. We collect data like it's nobody's business. We collect torque. We're collecting angle. We're collecting performance data, traceability, serial numbers. But it all goes in to a server, and you never see it again. The quality, if there's any quality people in here, usually the only time you look at that data is when you get a customer call. And then it's like, okay, so now we gotta go back. We gotta start digging. It's reactive data, right? So what we've done is we've taken our machines that's collecting all this data. We have about 30 manufacturing lines in our plant, and trying to take this data and collect it so we can actually understand what we're trying to do. The drive to Domo for me was we had a quality issue, and I had to provide data to our major OEM for our facility. In doing so, I was looking at Excel spreadsheets, Access database, handwritten serial numbers. Yes, a $35 billion global company is still writing serial numbers on pieces of paper, right? And I'm then trying to grab all this data and then trying to use Excel and doing some what-if algorithms to try to marry stuff up. It was a nightmare and a headache. It was killing me. And so our corporate brothers in Michigan were using Domo, starting out using it. And I was looking around for some other stuff, and I'm like, there's got to be a company that I can grab all this data, and then I can actually start pulling this in together for this traceability. Because we machine different components, and then we bring it on to the assembly line, and then we have to try to scan it, but we didn't have that capability of doing that. But again, there was data everywhere. It's inefficient, and it's manual, right? This guy, it's not me, he's way better looking than I am. However, this is what I look like. It's on this computer, and I'm doing this. I have 4 screens up, trying to bring everything together. When you look at the 4 M's, man, method, machine, material, right? Man is the most risky. It's the most risk to your processes. It's error prone, it's time consuming. There's waste into that. Part of that, and part of our reporting at our manufacturing plant, this is called our Hoshin area. So every morning, us managers, we go out there, and we have to go out and we literally go and we take these reports down out of these plastic sheets, and we're using a ruler, and we're charting. Yeah, you're laughing, I know. Can't believe it actually happens, right? This is 2018, not 1970s, but the process is good. The process and what we're trying to capture, it's good, but it's not digitized. It's stuff that happened the day before, right? If you can see in the picture,
or months before,
there's a monitor there. Now there's irony in this, right? Because it says this is our heartbeat. What's our operational efficiency? But yet the monitor's turned off. It's never on, except when we want to pull our phone out and we mirror image it to look at a little picture or something. That's what we do, and I'm like, come on. You know, it's waste. The Japanese use the word muda. It is wastefulness. Now, my vice president would probably kill me if I said this was waste. It serves its purpose. But what if all these boards, what if they were truly visual monitors? And you're getting data from our manufacturing lines happening live in real time. And I'll talk about that in a minute. Continuous improvement, Aisin, right? You're always trying to improve. So as a basketball coach, you might win a game by 20 points. You might have a defensive efficiency rate of 0.85 points per possession that you allowed your opponent to score. You might have had an OE of 1.1, and you won by 20, but yet you're getting on your center because he went 5 for 10 from the free throw line. Man, you gotta get better, right? So you can always improve. There's always continuous improvement. So when we start looking at this, I'm like, man, we gotta do something here. So what we did, we asked the business question: how do we get better? How do we reduce customer calls down at the customer's assembly plants? How do we keep defects from getting out of our plant? Right? How do we not lose I say lose, lost, cost. But every time you have a defect, every time you pull a transmission off the line, that's cost. Anytime the machine's down, that's cost, that's downtime, right? We're not capturing it. We would have downtime, machine downtime, and this is no joke. We get these pass downs, and our supervisor in this pass down would say we had an hour and a half of downtime for this machine. So you go out there and you ask him, say, well, what was going on? Well, it was rolling way down for 20 minutes, but he stated an hour and a half. Well, that's inefficient, right? We have the power to take that machine and say what the issue was, how long's it been down, calculate the cost of it being down, and then push it out so people can see it. We had to connect and prepare. We have all these systems, the PLC system, iGear, SQL servers. It's all going in, right? But then how do you actually strategize to get this to come out so it's effective? And then visualize and engage. We have some and-on boards that are in our manufacturing lines too. And it just shows very minimal stuff. Okay, it doesn't tell you anything. And then the last is review. So again, this is part of the PDCA. After we get these KPIs out, we know we want to start measuring. How are we going to start reviewing this data and then making improvements? Again, it's back to continuous improvement. The strategy, we had to start with a single line. I had 30 manufacturing lines, so I decided to start with our largest line that affects our largest customer. Not to say that other customers are not important, but I had to start somewhere, right? Our current layout, we're starting from scratch. So there's a bigger vision of trying to create some type of standard for what we're doing for our other North American plants and then our other global plants. What data sources do we want to grab? What are the critical KPIs and what actions is going to drive? So this is my blueprint. My blueprint was going down and then taking, I got this work cell here, I want to start gathering information. I have this sub-assembly line here. I have the main assembly. We have performance testers. There's data there that you need to grab. So we started building all this. And this blueprint then has now turned into this. So these are all live cards now. We're now being able to track traceability. We're able to tie every piece of that component at the end of our main assembly line with the touch of a button. Operational efficiency, first pass yield. We were pulling transmissions off at an alarming rate, but no one was paying attention. And about a year ago, I'm like, I gotta know what we're pulling off. Well, come to find out, we're pulling off about 2% of our daily production. So 2% on a heavy transmission, that costs a lot of money, those dollars start adding up quick. Capability tracking. This is the biggest one for me. Capability and statistical process control. These two keys, and really trying to show our customers how we're monitoring ourselves, and especially when you get into safety, where there's nits involved, being able to show how you're monitoring it live. And when I say live, I'm talking 240 seconds, this stuff updates. You can see it happening. And then how do we monetize our activity? This becomes kinetic. You start to be proactive. You start to get to be more now predictive. Start to involve machine learning, right? So this is one of our control charts, SPC. This is a rolling 30-piece capability. So those of you that understand capability, you have to have a 1.33 safety critical items, you have to have a 1.66 CPK. This shows your current capability. I have my spec high and low in the red. The green is my control chart. And I have a yellow in there, and we're still working on that with our Domo guys, to show yellow as part of our sort of like yield cautionary. Nathan Lingwall, my ADI guy, I keep trying to challenge him to fix this, and